And obviously Sleeping Moray made loads of errors as well.
Yeah, it became a meme on a far bigger channel.
Oh, yes. What, recently?
No, it was like shortly after
At the
debate.
time. Oh, I see.
Yeah.
Okay.
No, I missed one.
We are online, I think.
Yes, we are.
This data.
Nothing in Discord, I'm afraid.
No, but we're online on the stream.
Oh, so Discord is not streaming anything at the moment?
Yeah.
Then let me just... hang on. There we go.
Ah, yes.
So to the audience, can you guys hear us?
Are you unfortunate enough to be able to hear us? I'm gonna say yes.
I think so.
That's a definite maybe.
So, welcome everybody. Hi, Micro. I actually forgot to mention you in the stream earlier. Actually, Micro did most of the work when finding the sources. I just, converted everything to UTC and put it into the nice diagram.
I did the data collection.
Yes, he did. I'm sorry to forget that. Hi, Jared. How are you?
I'm doing all right. This will be a nice little fun distraction before the wonderfulness. Yay.
So, who else do we have? Hi, Planner Walk.
Ahoy hoy. How's it going?
Pretty good, thank you. And yourself?
That's going fairly well. It's early, but nothing that I haven't been able to deal with before.
Sorry for waking you up at this very early time. And last but not least, Rumpus.
Hello, Gio. Yes, yes, I'm still recovering from New Year, and I've currently got some stuff to sort out. And of course, I'm working still on doing my Rect presentation that obviously everybody who I've sort of vaguely mentioned it to is desperately eager to hear about, and you will be hearing about it very soon.
Yeah, we are waiting for it desperately. That's true.
That's right. Yes, I know. Micro's desperate.
Very.
So, what do you think about this?
Yes, when you mentioned it first of all to me, I had a quick, as I mentioned to you, I had a quick, without thinking about it properly, thinking that there were ways that you wouldn't necessarily expect all the things to follow a great circle. And it's only when we had a quick think, I was thinking, oh, hold on, the way these things work, waves, is they only travel in one direction. I was thinking that if you were sort of near to it, it could sort of swerve round on a line of latitude or something and come get you without having to go around the world. But of course not. That's not the way waves work. Anything that moves in any direction, if you move in any, maintain your direction like a wavefront does, and the perpendicular and the direction of travel is perpendicular to that, any direction on Earth will follow a great circle always. If you hold your bearing, or if you look at a star or something, or you have anything that's traveling in one direction, it will naturally follow a great circle. So there's no way it can sort of sneak round on a line of latitude to you. It's got to go all the way round on a great circle around the Earth and come back and get you. If it's going to do that at all, it's not going to use any other path. If it's proceeding out on a spherical, not spherical. I suppose it's not quite a spherical wavefront. I don't know what you call it actually. What's
circular?
Circular wavefront, I suppose. Yes, except that it's a sort of 3D circle thingy. Yes, so circular wavefront anyway. That only way it can get back to you is actually coming up. Going all the way around a great circle and coming back to you and getting you from behind or whatever if you're facing something. So if you it's like sort of firing a bullet or something was following the curvature of the Earth. Yeah. It has to follow a great circle to then come and hit you in the back.
The wave is in orbit.
Yes.
Yeah, because keep in mind, it's the great circle routes that things follow around the Earth is quite literally the shortest path it can take. That's the biggest thing. It's going to take the shortest path to get from point to point, whether from the static origination to random observer location that you pick.
Well, that's my trouble. The shortest point, if it's going past you, would be not have to go around the world. I mean, if you're Tonga and you're the second one, and if it was able to swerve, then it would not take the shortest route to use. Obviously, it's got to go around. The only way it can do it is via following a great circle.
Now, what I would suggest we do is we actually now go to the data and take a look at it in detail.
Yes.
So,
because it's quite fun.
Yeah, it is very, very good. So, first of all, this data is clustered currently in two major locations, which is, well, basically where, most or more people have barometers and more people have, access to Twitter. One of them being Europe, the other one being North America. So off of these 8 or 9 data points that I have here, 3 of them are in the US, and the remaining ones are in Europe.
But they're in different places in Europe.
Yes,
even within the same country, we can see differences.
Yes, even with this limited setup. And by the way, I challenge everybody to try this yourself. Just find somebody who measured to both locations, both pressure waves on Twitter, and who also gives their location, and do the calculation yourself. Obviously, you have to first of all, convert everything to UTC, and then add up the two times or the two durations.
Well, you don't have to use UTC. Yeah, but you can use any time as long as you convert it.
Right. Consistent. Anyway, so let's start with the 3 data points in the US. Now, in the US, the pressure wave moved approximately from west to east. And fortunately, we found 2 data points in Washington State, one being in Seattle and one being further east at an airport. And the third one was in New Jersey. That's on the other side of the continent. So let's just zoom in a little bit. For the Washington State and for the Seattle data point, the first pressure wave hit at around 8.5 to 9 hours, and the second one after approximately 11.5 hours. Now, if we go to the other side, where we actually see the second pressure wave, you see that the one in New Jersey hit first, followed then approximately 3 hours later by the ones in Washington State and the one in Seattle. So you can already see how the pressure wave is moving in the US from west to east. Now in Europe, the shortest path for the pressure wave, I can actually show this to you. Let's actually start with the US. So if we zoom out here a little bit, go to the US, you see it's coming from kind of southwestern direction. So Washington is up here.
Yeah, make the point what you're doing here, G. I mean, that effectively the one of those lines is the direction of the wavefront, and the other thing is the wavefront.
Yeah, exactly. So the line that connects Tonga to my mouse cursor, that's basically the direction of the wavefront, and the wavefront itself is the circle that I'm currently painting on this globe here. So if it moves across the US, as I said, Washington State is up here, Seattle is there, and the airport is somewhere around here. Those hit first, and then a few hours later, you hit New Jersey, which is approximately here. Now, when it comes to Europe, the quickest route to Europe is actually from the north. So we were fortunate enough to find a data point in North Sweden.
Even more north than that.
Even more north than that. Holy moly!
It's north of. It was north of Iceland.
Let me just northern this properly. There we go. North of Iceland, even. Holy moly! Yeah, that's all the way up. So we have one up here.
All the way up. It's a tiny little place.
Yes, we had one in Scotland, a second one in the UK, one in Bavaria, one in Switzerland, and one in Slovenia. So if we go to the data set, we see that the one in North Sweden was first, then the one in Scotland, then the one in southern UK.
That's Brighton. Yeah, that's in Oxfordshire. That's actually I'm familiar with that place.
Yes,
it's that's not far off.
Then the one in Chieming, that's in Bavaria, next to the Chiemsee Lake, and then the one in Slovenia and in Switzerland, approximately at the same time. And you see how symmetrical this is, right? The one where the second shockwave hit first was in Slovenia and in Switzerland, followed then by Chieming, then Bryce Norton, then Scotland, and then North Sweden. And again, this over here, this is just both of those two numbers added up. So this is basically our error bar. And you see that all of it clusters around somewhere between 36 and 37 hours. And this represents the time it takes for the shockwave to go around the entire planet exactly once.
The European ones are all in a line. It's the American one. The American ones are all over the shop.
Yeah, that's because
if you look at that line, if you've got to look at all the European ones, they all agree.
Not really. I mean, the North Sweden one is more.
Okay, sorry. Okay, all right. The North Sweden one. Okay, okay. That one's a bit of an outlier. All right.
Basically, the New Jersey of the US ones, the New Jersey ones is the only one that's out of line.
Yeah. So there's 2 reasons for this, or for the inaccuracies that can happen here. First of all, we couldn't resolve the time of the explosion closer than 10 minutes. So obviously, we already have a 1/6 of an hour of error. Just because we don't know exactly to the second when the explosion occurred. And then second of all, Earth is not a perfect sphere, it's an oblique sphere. There's actually a few hundred kilometers of difference When it comes to the polar diameter, radius and circumference, well, radius like something like 40, and circumference like something like 200. So this is actually relevant for places that actually get reached first over a polar route, which, for example, would be Sweden and Europe. And this is not the case for the US.
And then of course there's also the fact that we had to like estimate the times.
Yes.
By drawing lines on pictures from Twitter.
Yeah. So let me just show you the raw data. Let's just pick a random one. So this was the one from Slovenia.
This is one of the uglier ones.
Yeah, this is one of the uglier ones. So we basically had to estimate when does the pressure wave get more significant than the background noise, and then use that that is the impact time. So obviously there's a bunch of errors, and I think we hit it to about plus minus 15 minutes actually quite well.
Try finding one of the ones that actually, because this is a little, it's hard, especially the second one is hard to see. Yeah, much better.
All right, fair enough.
Especially the first one there, the left. At what point do you mark it as there's the most likely point of the pressure wave actually hitting?
Yeah, basically we decided once we think it's outside of the background noise.
Yeah.
Because we can't we can't use the middle of the pressure wave because that's already past the impact point.
Yeah.
You want to hit it a little bit early.
And those kinds of, and the exact signature of the wave is going to change depending on the surroundings. So you can't, and air currents and stuff, so you can't just say, like, choose the same points at every location because it looks different at the different locations.
Yeah. Also, in some of the cases, it was barely noticeable as a signal at all. It was barely across the background noise. So there are certain inaccuracies. If you find better data, then go ahead and try it out. But it's already, in my opinion, pretty consistent.
Yeah, it's remarkably good.
Yeah. And most of these are just like off-the-shelf barometers or weather stations that people just have because they're interested in weather.
Okay, so somebody's asking where the antipodal point is. I can show you this quite well on Google Earth. So if you actually just use the circle functionality and you draw it all the way on the other side, it shows that the antipodal point, well, this one is a bit off, but okay, is somewhere in North Africa, in southern Algeria, in the middle of bumfuck nowhere.
There's probably something there.
I mean, there's sand.
Yeah, that's something.
Great.
It has to be air, otherwise the wave can't travel. That's not nothing.
Yeah, so you see that Europe is actually quite close to the antipodal point, while the US is much closer to the volcano, and you can see that directly in the data.
And of course, that means that the two will meet at the same time. Those two things, so the separation will be very tiny near there.
Okay, so Dora is asking when the times in UTC or CET are, when we should have noticed this in Europe. It was
Depends
around
on where you are.
Yeah, but it was, just assuming that you're in the middle of Central Europe, it was around 8 p.m. our time, which is 7 p.m. UTC, thereabouts.
Yeah.
Again, remember that sound waves are comparatively slow. It's only about a kilometer every 3 seconds. So depending on where you are, it actually makes quite a difference. And our data shows that if you just compare North Sweden to Switzerland, there's almost an hour difference.
And how long does it take to do? What's half a circuit around the Earth? How long does that take?
So
depends on how fast you move.
So one full circle, one complete rotation around the planet, according to this, is 37 hours.
Yeah.
So that fits actually quite well. If the circumference of the planet is 40,000 kilometers, then that's a little bit faster than 1,000 kilometers per hour.
Which,
that should be a little bit under being supersonic.
Yeah.
It's right where it should be when you start to consider a lot of the atmospheric variations that it's going to encounter that will allow it to slow down, speed up. As is already pointed in the chat, when it hits the colder air masses, your travel time of the pressure wave is going to vary.
Yes, there's also going to be cases where it's going to refract around mountain ranges, things like that. So it's not perfect, but it's pretty good data set in my opinion.
Yeah, because remember, the speed of sound is dependent on temperature and pressure, and those things are obviously going to vary. And as we were saying, Alex, probably it comes as an average or something for all the way rounds. But some of them might be going over the poles and things, and therefore to be colder, and with that changes the density.
Well, it also just traveling over the giant fucking ocean that's between it and the US probably also had an impact.
I mean, I find it pretty insane that people in Alaska could hear the sound. That's 9,200 kilometers away.
Yeah.
Oh, right. What's the furthest? What was the furthest it was audible?
As far as I'm aware, it's Alaska.
Right, that's still a long way. Yeah.
There were expectations that it might have been audible from Europe, but I have not seen any reports that confirm this.
Well, keep in mind, there are other factors into it being audible and why Alaska is actually a prime candidate for it, because you have very little landmass in the way to distort it, and also most of your locations in Alaska are very sparsely populated, so you don't have a high ambient noise to deal with.
Yep. Apart from people shooting bears or each other, I guess. So for the people that just joined, basically, just by using Twitter data regarding the timings on when the shockwaves of the volcanic eruption yesterday have been recorded, we can directly prove that Earth is a sphere. And I'm really curious to see what the reactions of flat earthers is going to be.
It reflected off the dome. That's what we're going to say.
Well, here's the problem with that is there would have been a lot more reverberation if that was the case.
Maybe
the flat earthers care about that though.
No. Maybe
I'm not saying they wouldn't say it. I'm saying the counter to show that it's full of shit is, well, if that were the case, then where are all the other reflections and reverberations of it?
But you're forgetting something. You're forgetting that the dome is made out of special material that only reflects the sound once.
Ah, yeah, the good old special pleating.
It's not quite an anechoic chamber, but it's a almost anechoic chamber.
No, I'm really curious as to see on whether we can actually measure this going around the globe again.
No. You probably can, but I don't think it's gonna show up in the weather barometers around
I don't think so either, but at least for some of the earlier big volcanic eruptions, Pinatubo was one case in 91, I think. And obviously there was Krakatoa in 1886, maybe 1883, can't recall. Yeah. They measured that going around the planet a few times.
Did they really?
Yes, they did 2 or 3 times. Yes.
Yeah.
Bloody hell.
So this is not as big as those ones, but Pinatubo was, I think, a 5 or a 6 on the volcanic eruptivity scale. So was Pinatubo and Krakatoa were. This one is probably just a 4.
Just a 4.
Yeah, that means it's by an order of 100 smaller. Because remember, the scale is logarithmic.
Yeah, and of course Krakatoa is of course the loudest noise any human has ever heard.
Yes. Krakatoa was measured at 310 decibels. Yes. 310.
Well, it's the largest that's been measured, because I think there was a bigger, was it Santorini or something was supposed to be a bigger explosion than Krakatoa. But yeah, and certainly in modern times where we've actually had instruments to measure it, Krakatoa would be the loudest.
Yeah, Santorini was also quite an event.
Yes.
I mean, it's typical for these islands just, blowing up, because they just soak full of water and then go up like a pressure cooker.
Yeah, I mean, Krakatoa has gone up there's a number of times it's gone bang.
Yeah.
Yes, and, the last one was in 2018.
Yes, I was thinking of big ones where the islands were sort of ripped apart and it left a hole, and then there'd be new.
Then it slowly starts to build up a new island. Yeah. So it's like you get these weird ring structures.
Yes.
So it actually, a new satellite imagery has actually already come in regarding the explosion yesterday, and it looks like the volcanic island is completely gone.
Yes, it is.
Really?
There's just a big fucking. There's there's still parts of the island left, but there's a big circular hole.
So let's just have a look at this.
Remember, it's actually 2 islands that's grown together because there's 2 outlets.
So let's just go into the geography of the entire thing. So this is a volcanic island. Obviously, this picture is now a little bit outdated. And it's important to know that this is not really the volcano. It's just a part of it. The entire volcano is more this entire area, where the two islands here and the volcano chimney that has currently formed, that's just basically on the rim of the caldera that's underwater. Now, it looked like what happened at a big part of this volcanic mountain just slipped into the ocean. And that then just took pressure of the system, which then just blew up because there was nothing else to hold it back together. So the newest satellite pictures basically show that this part in the center is completely gone. And both of these islands on the side, which you can actually see are a little bit taller. You see that? So that one's basically flat.
I presume they're uninhabited.
Yes, they are uninhabited.
Yes, they are.
At least by humans.
But
I mean, there's
the big islands next to it aren't.
Yeah.
Yes, Toga, obviously. Yeah, because Toga's not very far away, is it?
It's like 70 kilometers. It's pretty close. Yeah. Anyway, in any case, both of these two older islands, they're almost completely gone. And there's just a little part of this one left and a little part of that one, but most of the mass is lost. Regarding the environment, so the main island of Tonga is down here. Let's just measure the distance.
I wouldn't say that it's lost. It's just been violently and quickly relocated.
Yeah. So that's just 65 kilometers away. The volcanic plume that formed increased to a size of around 500 kilometers in diameter in about 2 hours. So communication to Tonga was actually lost. I don't know if it has been reestablished. It turns out that one of their undersea cables that connected them to New Zealand, one of the transmitter stations was damaged in one way. And obviously the satellite communication is completely gone because you can't, transmit through a thick layer of ash clouds. It just doesn't work.
I think I heard it was reestablished.
It was reestablished. Do you know of any fatalities?
No, I haven't. I haven't been keeping up 100% with this, but yeah.
Plainer, were people able to hear it clearly in New Zealand?
I didn't hear it. I think there might have been some reports of it being heard in New Zealand, though.
It was confirmed to be audible in Auckland.
Well, I guess it also doesn't help that there's a big, New Zealand is just like a big, long range of mountains, so depending on which side of them you are on, it's good.
Yeah, I think if I were to probably go to maps, it would show it having to travel through mountains to get to me. So
yeah, that's what I was thinking, because I think it's probably going to be pushed upwards and reflected going around the mountains.
Yeah. Yeah, so people on the coast obviously be
where there's nothing.
Yeah, so Fiji was hit by a tsunami quite badly. Tonga was probably hit, but we just don't know. And there was warnings for the west coast of the US, for Australia, for New Zealand, and for apparently the worst that it hit outside of the immediate area was South America, where there were actually a few fatalities. So yeah, not great.
Is that a trench just on that edge of that thing of moving?
Yeah, because this happened. The reason there's a volcano there is because you have the ring of fire going all the way around the Pacific plate.
Yeah, so what's basically happening here is that the Pacific plate is submerging under the, I guess that's the plate of Zealandia, isn't it? It's like a kind of submerged continent. I'm not sure, actually. Anyway, what's happening is that the Pacific plate is submerged under the other plate and then starting to melt. And that's basically what's fueling the volcanoes there.
That's also why it's slightly inwards from the... it's not on... the volcano doesn't happen where the plates go under. They happen inwards where the plate going under being subducted has gone far enough down to start to melt, and then it bubbled. The melted rock will start to.
Yeah, and you see that on all major subduction zones. Also on the other side of Indonesia, right? That's where you get the big earthquake. Where you got the big earthquake from in 2004. That's also why Sumatra and Java are just basically lines of volcanoes. And
Australian plate is
Is it the Australian plate? Okay.
Yes.
Yeah, the same is true on the other side of the Australian plate.
I mean, that's why you have volcanoes in Europe as well, because the plate, the African plate is moving upwards.
Yeah, that's why you have Etna and Vulcano and Stromboli and Vesuvio.
Yeah. And with those, they're even further away from where they actually meet.
Probably even more dangerous considering how close they are to civilization.
Yeah, they must be because there's a plate joint going through Greece, isn't there? I think around there.
The plate joint is like, it's like, it's mostly following the north coast of Africa.
Yeah,
and then
I don't think you're right. Isn't it already the well? That's why the Alps are forming up, right? So the southern part of the Alps should already be African plate.
No, the plate goes plate boundary follows the north of Africa until you get past east of Italy. Then it has like a little tip up into Greece, and that's why the volcanism is called.
Isn't there an Adriatic bit? Oh no, okay, right there.
It's a bit more chaotic.
There's obviously the plates are there are a bunch of like micro plates and stuff. It's not a nice clean line. It never is.
So you see the southern end of this main zone seems to be about on Crete, the island of Crete. And it goes right through Italy. Etna is right here. And the chain of volcanic islands is about here. Vesuvio is up here somewhere.
Yeah.
Yeah, see Greece. Yeah, see Greece is the one that's suffering most there.
And then you have the complete package with Iceland, where you both have magma coming up because the Mid-Atlantic Ridge is spreading apart, and they happen to have a hot spot there.
It's got the hot spot as well. Yes, right.
Yeah, so it's like it's just all the ways you can make a volcano.
Yeah, because that's right. Because I mean, I did people know Hawaii's right in the middle of the Pacific Plate, but I don't think that there's no joint there. But it's there's a great big hot spot underneath.
Yes, actually, that's exactly what Hawaii is. That's also why it has this line of islands and undersea volcanoes, undersea volcanoes behind it. Because it's basically just the Pacific Plate moving over the hotspot.
Yeah.
And the Pacific Plate, I think, is it growing on both sides?
No, it's moving towards Japan, which is why you have the big volcano chain in Japan.
Right, so it's not subducting underneath the US then, right?
No, it's growing it's basically growing from the American side, sliding over to Japan.
Well, remember, there's also another plate in between it and South America.
Yeah, I mean, there's smaller plates. Yes, that's correct.
Yeah.
That's also why the volcano under the Yellowstone is slowly moving eastward. It's also a hotspot with America itself moving west.
That's going to be a biggie. Yes, I'm looking forward to that going up.
Yeah, probably not going to happen during our lifetimes, hopefully, because that would suck.
Hopefully not. That
would be a big.
Hopefully, we've made it to Mars by that time.
And there are volcanoes on Mars too.
Yeah, but
those don't do anything.
Not working ones.
Yeah, but we can fix that. We can make them work again.
I think you need to. I don't think the physics is going to say that we can do that.
No. So let's actually have a look at the explosion itself.
With enough energy, you can do anything.
Yeah, exactly, but that's the problem.
So this is satellite data from the Japanese Himawari 8 satellite. So Tonga is here. Let's just go through this frame by frame. So this is in UTC. 350, nothing. And then at 4 o'clock, you see this little plume here, just for comparison. Do you see that? And then 410.
Oh my god.
420. 430. 440. 450.
You can see the shockwave.
5. Yeah, I'm just gonna render this in a few seconds. 510, 520. Now, interestingly, luckily this happened right at the time of sundown, which really gives us a little bit of a view on the top, on the structure of the ash cloud, I guess.
Yeah, I hadn't researched the pictures before. That's just an amazing thing, isn't it?
Yes,
as you say, with the sunset thing really adding to it. God,
yeah, you can really see that it's hitting it like it's hitting some layer in the atmosphere.
Jesus!
Now, if you let this render a bit and turn it into this little video, you actually can see the sound wave.
You can see the shock wave.
The reason why you can see it is
that
the little changes in atmospheric pressure actually cause condensation.
Right.
The pressure going down causes water not being able to be vaporized anymore and precipitating as little droplets, and that's what you actually see as a shock wave.
That's amazing.
I actually measured where it was and tried to figure out the speed, and it's pretty well in agreement with what we saw from our data set.
Oh, you should go find there's tweets of both. I can find them while you talk. There's tweets of both that have animations of weather stations in the US and in Japan where you can see the wave passing over in the data.
Also saw one for Germany. Give me a second, I'll find it.
It's just you couldn't imagine how much better it could be giving a shockwave. I mean, that's an amazing picture of a shockwave. It really is incredible.
It looks really great.
Yeah. So here's one for Germany. Just give me a second. So this is the pressure.
And to imagine that NASA
goes from north to south.
And to imagine that NASA had to like right after they knew that there was an explosion, a volcanic eruption, they had to go in and change the algorithm and so that the CGI changed.
Right.
That's amazing.
Yeah, that's some hard-working programmers there.
Yeah.
I mean, it's beautiful and shocking at the same time, isn't it? Absolutely.
Well, it's literally shocking.
Well, hopefully. So, how many casualties did this cause? So, if it's not,
we don't know fully yet. I don't.
I mean, you're saying we didn't. Someone was saying we didn't actually know what's happened on Tonga yet. Was that no? Alex was saying.
Yeah. So communication with Tonga was interrupted. I'm not sure if it's up yet. Last time I checked, it wasn't. The only fatalities that we definitely know of so far happened in Peru, where 2 fishermen drowned because of the tsunami hit them.
God, the shock is just amazing. It caused that condensation. Right, I was wondering what that was. I suppose it's condensation. I suppose yes, quite amazing.
What is the comparison to Vesuvius or Terra? I wonder. So Vesuvius, I'm not sure. Let me have a look. This explosion that you can see here now, that is approximately volcanic eruptivity index 4, maybe 5, depending on who you ask. The one at Vesuvio was a 5. Mount St. Helens, I think, was also a 5. So it's the same kind of caliber. But you cannot compare it to Pinatubo, you cannot compare it to Krakatoa or anything that's bigger.
Well, you also have to always remember that there are different types of volcanoes that act differently. So
Neslik is asking if it spread a lot of sulfur into the atmosphere. I don't know. It's very likely that the big chunk of the cloud that you're seeing here is just water vapor, because after all, large parts of the volcano are underwater. And the actual ash part of it is significantly smaller than the entire thing. But
which of course is not actually ash; it's pulverized rock.
Yeah, it's basically glass, if you think about it.
Yeah, volcanic ash is not like the ash you find in the fireplace. It is like fine dust of needle sharp little.
It's basically pulverized asbestos in terms of consistency.
Yeah. Like
it's
breathing in volcanic ash is like fucking dangerous because it ends up just shredding your lungs, and you end up drowning from the inside in your own body fluids.
Oh, that sounds fun.
Ouch. Just micro to drag it down to that. Something. Some biological trauma.
It doesn't sound fun.
Oh. Sounds horrific. I mean, there were all these accounts, I think, of other volcanic explosions. I can't remember where now, where the ash, what are they called? Pyroclastic flows or something.
Yes.
And there was some guy, I think it was somewhere in the Caribbean, where 100 years ago or something, was in a prison or something.
That was Montserrat.
Oh, no, that was a few years ago. I'm talking about one where some guy was in a prison or something, and a glass bottle actually melted in this prison that was, I don't know, 40, 50 miles away from something.
Wait a second. That was Sophia Hills, I think.
And the poor guy in the prison, and it just burns your lungs from the inside. Oh, God.
Yeah, because pyroclastic flows is what happens when the ash cloud collapses, and instead of being in the air, this cloud 500 degrees Celsius cloud of ash and hot gases starts basically being an avalanche down the side of the mountain.
Have you seen so presumably you've seen those pictures of some of those pyroclastic flows.
What you mean, Rambus, is the 1902 eruption of Mount Pelée on Martinique.
Ah, yeah, Martinique. Yeah,
which killed everybody apart from one survivor who was sitting in prison.
Oh, whoa, he survived, did he? Right, okay.
Yes.
Right.
Apparently, that's... What are the blue lines, by the way, on this?
So this is actually meant for tracking storm systems. So the blue lines actually track storm systems.
So it's tracking that makes sense.
Yeah, we can switch those off if you want.
No, it's fine. It's
somewhere.
Yeah, that example, and as I say, there were glass bottles that were outside, and they were just melted. That Martinique thing, just unbelievably horrific.
Yeah, those pyroclastic surges are not to be underestimated. They also that was one of the two things that actually killed all the people around St. Helens, right? The other ones were the molten glaciers flushing everything away.
And of course, it flattened it was the pyroclastic flow that flattened all the trees around Mountain Helens.
Yes.
Yep.
Well, it also didn't help that it fucking exploded and fell apart.
It also didn't help that it exploded to the side, which meant that many of the pyroclastic flows actually exceeded the estimated range of them.
Yes, that's what confused them completely, wasn't it? It was the fact that it was a side explosion. All the models are going upwards, and then it was the side explosion that screwed everything up.
Now, when it comes to St. Helens, right? Let me just... is it Oregon? No.
Is that a hot spot underneath it, or is it a plate junction?
That's a plate thing. It's the same thing that causes the San Andreas fault.
All right.
So Mount St. Helens, right? That's that one. This one. Now, as you can see, here's Mount Adams.
There's a lot of volcanoes.
Mount Rainier, and that just continues. So, Rainier is actually due to do the same thing. And that's significantly bigger in potential energy surge than St. Helens is, apparently. It also doesn't help that it's much closer to, the more populated areas. I mean, this over here is Seattle. Here's Seattle. This is Redmond, Tacoma, Olympia. So when that thing pops, that's it's also going to be a lot of fun for them.
Of course, now they just since the Mount St. Helens eruption, we have gotten a lot better at predicting and modeling this.
Yes,
in large part because of the increase in computing power.
Yeah, I mean nowadays they're saying things like you can determine how something's close to going just simply from the gases that are being emitted from the damn thing.
Yes, they've started measuring that as well, and you'll have measuring stations all around, anywhere there's gas seeps, and there will be the volcanologists will be following that.
There was a famous incident, I think it's about 5 or 10 years ago, when there were two competing people who were saying when this volcano, I think it was near Turkey or something, was going to explode. One was basing it on the gases being emitted, and someone else was talking about on the
earthquakes and stuff.
Basically earthquakes, the seismic information. And I think it was the gas guy. He said no, it's going to go very soon. The seismic people said no, and they got caught on the damn thing. It went bang and killed them all.
Yeah.
Oops. I think it was in Turkey or somewhere around there.
Pro tip: if you're not sure whether a volcano is going to blow up soon, just stay away from it.
Yeah, that seems that. Yeah.
Well, the trouble was there was that one in Southeast Asia, wasn't there, where they kept on having. It was right next to a large town, and they didn't want to give false warnings of having to abandon it, and then they did actually get it within 24 or 48 hours that it's going to pop, and so they actually abandoned. I think it was 1 million people or something, 500,000 to 1 million people were only within 5 miles of the damn thing.
That might have been Pinatubo.
Yeah, it might have been. Yes, actually, I think it was actually. Yeah,
there was one last year in the Philippines called Tal, which is kind of the same caliber. That was infamous for having the only island in the lake and an island in the lake on an island.
Another ring affair, I mean.
Yeah.
Right.
I do want to mention how the New Zealand government managed to make contact with the New Zealand embassy in Nuku'alofa. I may have butchered the pronunciation.
Okay. Yeah, that's the capital of Tonga.
Yes.
Oh, right, they got through. Oh, okay.
And is there anything that they are reporting that would be significant to know?
No, they say there are no official reports of injuries or deaths in Tonga as of yet, but the communications were limited and contact has not been established with coastal areas beyond the capital.
Yeah.
Okay,
it's gonna take a bit.
They're probably stuck in large ash falls.
Yes,
which is a problem. I mean, that's a problem for everything, right? That probably means that you can run your car only for a few minutes before the filter clogs up.
Good point. Yes.
Right, so they're basically down. They should wait until everything has settled.
Yeah, that Pinatubo, whatever it's, I can't remember the name. The cars trying to run through that were having terrible trouble trying to do anything to get away from it. Running around.
Yeah, and then obviously there's the risk of the ash actually being so heavy that it collapses structures under it.
Yep. Yeah. Martinique, a lot of stuff on Martinique was having that problem.
Yeah.
Which you'll often, which is also why there's a difference between places near a volcano where they also have heavy snowfall and places that near volcanoes that don't. Because places that are near where there's heavy snowfall will be made to be able to handle more weight on top of them.
And as you said, Micro, the ash is all really pointy, so it sort of sticks to itself really well when it's landed. Whereas
it's because what the ash is that you have is basically you have the magma becoming lava and then being in little tiny droplets and then and then cooling down. So it's just these and then being pulverized. So it's just fragmented rocks.
Yeah. Then imagine what happens when it soaks up with water.
Yeah,
it's gonna get into this kind of crunchy, muddy material. It's just nasty.
It's incredibly it's an incredibly fine, incredibly sticky mud.
So regarding fatalities, to the person hold on in the side chat, there's no reports for that so far, apart from 2 people that drowned in Peru because of the wave. But to be honest, it would be quite a miracle if nobody else had.
Yeah, no, but still, yeah.
Didn't you say it was 3 meters? Didn't you say it was 3 meters?
Yeah, it was between 2.5 and 3 meters, depending on what source you look at. It obviously depends on the topography, right? Because whenever you have something like a kind of bay, the water actually gets funneled in that.
Yeah,
and just piles up.
Tsunami gets taller.
Yeah, I mean the one that caused the one at Aceh, the one in near Sumatra, the stuff that killed people it was only about 3 meters high, I think, the tidal wave. So yeah, 3 meters will
3 meters doesn't sound like a lot, but when it's a wave coming towards you, it's a fuck ton.
Also remember that it's not just the surface wave, right? It's the entire column of the ocean that's actually moving in a tsunami.
Yeah. Whereas
in the case of the earthquake in Indonesia, that was because basically a plate had snapped and just pushed the entire water above it a few meters high. Right, and then it's just flowing over. And the same thing is the one that happened in Japan.
Yeah, I was about to say the one in Japan. That was I can't remember what that was caused. Where was the origin of that one?
About 50-60 kilometers, I think, off the coast of Fukushima.
Yeah, Fukushima. Yes.
Yeah, it was. Yeah,
you kind of see it here, right? So you have Japan here, and here's the plate border. So it happened somewhere in that region.
Yeah. Yeah, not really. Yeah, some of the waves there, they got up to about a bit higher, weren't they? Those they about 5 meters or something.
I think even more. There were cases where they were measured up to like 15, 20.
Yeah,
Yes,
they're also
the topography had to be really, really specific.
That's right. There were some cars that were parked, that were ended up on the top of buildings, that were about a skyscraper car park or something. Ended up with cars that were down on the ground, actually way up 50 meters, as you say, 50 meters. Right now, I'm remembering. Yeah, bloody hell.
Yeah, that one was pretty insane. I remember watching that one live.
Yeah, that was.
That one was not fun.
Yeah. I mean, you could see those pictures. I don't remember the Japan. There was a crowds near the ground. You could see them. They could see they'd been warned they were coming, and there were all these people running up the sides of this hill, trying to get away from it. And there was all these little human stories of trying to evade the damn thing, and you saw these little those pictures of it going over the barrier with those boats and things, and oh Jesus.
I mean, the thing is that this can happen everywhere, right? On every coastline. In the Atlantic, there's this risk of which island is it? Is it La Palma? I think it's La Palma, isn't it?
Yeah,
it's one of the
one of those. Yeah. Which one? I'm not sure. Where basically half of the mountain is unstable and you can just slip into the ocean.
Yep. In fact, recently, I think there was a news story about that about 3 or 4 months ago, saying it was even more prone to doing. They'd spotted it was actually starting to do exactly what was predicted, i.e., half of it was going to slide into the sea. I mean, it doesn't sound too dramatic that an island, a bit of rock sliding in, but when you look at the mechanics of it, it's
half an island.
Yeah, I mean, you wouldn't have thought, half an island slipping, and okay, so what?
Yeah, but that's like a few dozens of cubic kilometers just, slipping into the ocean.
Yeah, but I mean, but somehow you think, it's a big ocean, it's slide in, no problem, it could all accommodate that. But no, when that's going to knock off, they're thinking when that La Palma goes off, it's actually going to cause an enormous tidal wave in Florida and etc.
Not only Florida, the entire U.S. East Coast.
Yeah, entire East Coast.
By the way, apparently the tsunami yesterday was measured all the way into the Gulf of Mexico. It was not significant, but they could actually see it. It had traveled all the way from Tonga through the Southern Ocean around either Africa or South America, and then up the Atlantic into the Gulf of Mexico.
What the hell?
Yeah, it was only 10, 15 centimeters, but still enough to measure it. So yeah, this is a worldwide phenomenon.
And it diffracts just like a wave.
Like a wave in air.
Yeah, exactly.
So
we'll
wave in water.
Exactly, and then that was what a lot of the stuff that caused problems in the Aceh one, the Sumatran one, where some of these places have got really suffered some of the diffraction.
Yeah, it's basically when you're behind an island, the wave can be refracted around that island.
And there's Ceylon, so there's Madagascar, at the bottom left there, and that has suffered quite. In fact, didn't they have about 25,000 casualties on Madagascar from the thing next to Sumatra? I
think they did, and they also had a few hundred in Eastern Africa still. Yeah, even though that wave only hit something like 10 hours after the earthquake, so there would have been enough time to evacuate. They just didn't get the info.
Yeah, I mean, just look at the distance there. I mean, Sumatra over there, top right, and Madagascar.
Yeah, there's a whole Indian Ocean there.
I mean, what has gotten a lot better since 2004, and especially after 2011, is just the warning system. You have just wired up the entire planet. So now the infrastructure is actually there to warn people. Right, and now also everybody carries around a computer in their pockets.
Yeah, I mean, because I think the reason that the Aceh was particularly bad on the warning was because the Pacific has lots of buoys in it to measure this sort of thing, but in the Indian Ocean, because happens less often, they didn't have the same system in place. So the Aceh one was therefore didn't have them. So people in Madagascar really didn't know because there was no buoys and things to detect. Because there was a very strange. The thing that actually was worst, I think, was there was a 200. There was a slight, something like 8 miles wide by something like 10 miles long, slipped or something in a sort of jutting out thing, which actually caused one of the major problems. And they weren't aware of that. And that's why Sumatra mostly got away with that. And it was actually most of the wave was actually directed, towards Ceylon and Sri Lanka and Madagascar, actually away from as well. The northern bit obviously suffered of Sumatra, but some of it's amazing how lucky you can be. Get a bay round the wrong way, and that's it. You've had it.
Yeah.
But if you,
I am gonna I'm gonna head out, guys.
Fair enough. I just want to point out that even here in Europe, we are not safe. There's enough places where, big piece of debris can just slide into the ocean. Where was it? Somewhere Norway, I think. So that can even hit the UK or even northern Germany and Denmark. Yeah.
I think there was an Alaskan one where there was a bay or something where half the thing fell off, and actually some people were fishing or something in it, and that and caused an enormous tsunami. And I think they managed to ride the damn thing.
There's actually a few cases of this not only happening in the oceans but also in lakes. Apparently, Lake Geneva is quite notorious for this. Every few centuries, millennia, I think, they show that there were pieces of nearby mountains just sliding into that lake and causing waves. Oh, who's there? Somebody joined.
Yeah.
Nestle, hi, you need to unmute yourself.
Hello.
There we go.
You hear me?
We can hear you just fine.
Well, I have to wait for 10 minutes before to join, but anyway.
I know that's a safety measure against people who just want to join and fuck everything up.
Yeah.
So what do you think about the entire situation?
Yeah. I hope it doesn't cause like a cold snap in the coming years. But I don't know, maybe it should be fine because it was underwater and maybe not a lot of sulfur was emitted. I hope so.
It appears to be too small for that. In terms of eruptive size, it's not enough to cause major global issues.
That's good.
Yeah, that said, there's a few bigger calibers that are overdue.
There's also one thing, and I also mentioned in the chat about Krakatoa. There was like one ship that was sailing nearby, and it actually survived. Like it experienced like very heavy ashfall. It almost made it capsize, and the captain decided that he purposely decided to steer into the wave in order to avoid having it capsized. Pretty smart.
Let's just have a look at Krakatoa for a second.
Yeah.
That's right there, isn't it? Between those two islands. Probably this one.
Yeah, it looks a bit like it, doesn't it?
That already looks pretty nasty. Let's see if we can actually have a look at different times. Oh god. Yeah, that's already different. Do you see that?
I cannot see your image or your stream.
I'm streaming. I'm also streaming into Discord. You have to click me and then say watch stream.
All right, they got records back to when? When's that's changed from? Right, so that's 1993. Okay. God, it has changed a lot, hasn't it? Jesus Christ! Over just 20 years or 30 years? Bloody hell!
I mean, recently the last eruption, the big one, was in 2018, right? And you can see that it's rather static before then. It's also like full of vegetation. You see that?
Yeah.
It's also pretty tall. Wait. Right, that's a proper volcano cone. And then if you go a little bit further, here obviously you see that there's like a lava flowing off of it. Yeah, and then it just completely fucked everything up in 2018.
Now I can see the stream.
Yeah, there we go.
Reload the stream, yeah.
I mean, there's nothing left.
Yeah, and that island was new. Like after it erupted, there was no island in the middle. But then a few years later,
Yeah, basically when Krakatoa erupted in the 1880s, there was an island before that, and that just completely disappeared. Yeah. And this one formed like something like 30-40 years later in the 1920s. It has been there ever since.
Yeah, I think the name means
this entire thing. It's incredible.
I think the name means child of Krakatau.
Yes, it does.
It's now enough. Yeah.
Yeah, I mean, all of these subduction volcanoes, they're just so incredibly dangerous. I mean, here you're kind of lucky that it's kind of, trapped between those two islands, so tsunami danger isn't that big compared to other places. But still, In 2018, how many people did it kill? Let's have a look. Sunda Strait tsunami 2018. Deaths 426.
Still pretty much like a good sized air crash.
Yeah.
Right.
For comparison, let's have a look at the one that hit where Krakatoa hit in 1880. That wasn't in 1880. When was it?
I think 1883.
1883. Yes. So that one killed 36,417 people, according to official numbers.
Probably a lot more because it also caused like a very cold year.
Yeah.
The following year.
I mean, I'm just talking about the direct consequences. But yes, right. It caused major crop failures even in Europe for a few years. The year without summer. That was Krakatoa.
Yeah. It's also interesting. The famous painting of a screaming man with the background.
Yes, the scream. Yes.
Yes. It's hypothesized that color in the background was inspired by the color change of that eruption.
Makes sense. So incredible.
Yes, it's.
Like during my high school years, I did a project on volcanoes, and I almost became a geologist because of it. Although I changed my career choice.
Yeah, I mean, this is all a result, of course, of obviously the internal energy of the Earth, which powers our magnetic field, and so we do need this. Unfortunately, if we want to have a magnetic field to protect us from sun's rays, I'm afraid we have to get all this geological activity.
Yeah, that's kind of unfortunate.
Yeah, it is. Right. I mean, something like Mars is now. I think Mars is now solid. I think it's a solid planet now, and so that's what it becomes geologically dead.
I think its core pretty much freezed. Yes.
Yeah, the thing is too small to hold its internal heat for the lifetime of the solar system.
And then that's what caused it to lose its atmosphere, of course. Because I mean, at one point it had water and things on it.
Yeah, the magnetic field goes first, and then obviously it's just going to be stripped away by the solar irradiation.
Yeah, that's right.
Solar wind.
Yeah.
Actually interesting. Like when solar radiation blasts the water vapor, it leaves behind the oxygen, because the hydrogen just escapes because it's so light, and the oxygen is left behind, and that's why the entire planet is red because of the rust of the oxygen left behind.
Oh right, so all the oxide, because there's no oxygen in the atmosphere at the moment, is there? I don't think.
Right. It has reacted with all the iron in the sand and such.
Yeah,
all oxidized. Yeah,
in forming peroxides and things as well, doesn't it? I think it's quite a lot of. It's heavily oxidized anyway.
So the problem with Mars, the color comes from iron oxide. But what you're talking about is not peroxide; it's perchlorates. That's the soil. It's contaminated with perchlorates, which are pretty lethal for microorganisms, at least on Earth.
Yes, right. So what you're saying that Mars has got a lot of perchlorates on it. I think you're right, actually. But where did the chlorine come from? I suppose
you find it everywhere.
I suppose that's true. I was just thinking we don't have much chlorine in our world, but of course it's all formed salt, hasn't it? Or something.
I would maybe imagine that the old seas of Mars were also pretty salty, perhaps.
Yes,
if it was.
Yes, you suddenly made me think. I suddenly think we don't have chlorine in our world, but yes, of course we do. It's all this salt and.
Yeah, but again, it also forms minerals quite nicely. So
yes, chlorates and things. Yes, and not chlorates, I suppose.
Chlorides.
Chlorides. Yes, I was thinking what other chlorides are. You see, obviously, potassium chloride, of course, is another favourite.
Yeah, but most alkaline metal chlorides are water soluble.
Yes.
Right, but there's enough minerals that are not, even though they contain chlorides.
What are they? Give me
some silicates, for example.
Right.
Fluorosilicates. So, yeah. You'll find the stuff everywhere.
Yeah, I mean, chlorine being, I suppose, so reactive, yes, if it's so reactive, it's going to go and react with something, isn't it?
Can you also go to Tambora, It's also a famous eruption. I
Tambora.
think it was like 1813 maybe or something like that. I don't know. But it was before Krakatoa.
So Tambora was the one that caused the year without summer, not Krakatoa. Yes, that's correct.
Oh, right. That's
right. Yes, it was around. Yes, that's right. It's around the Battle of Waterloo was the year without. Yes, so it wasn't Krakatoa. Yes.
But by the way, there's still some hypotheses that a late consequence of the year without summer was actually the Irish potato famine.
Oh right.
Oh right.
Yep. That the decreased temperatures gave better living conditions for whatever the fungus was called that fucked up all the potato crops. Yes.
Yeah,
I know that because of where I am now, and I'm more in plant biology with my career choice. It's all connected.
Yeah, because I think Krakatoa caused a year of mega sunsets. I think was the thing that it caused. Yeah, the year without summer was the one around the Battle of Waterloo or just before. Yes.
Tambora, yeah.
God, amazing.
Although I do think that the Krakatoa did cause like a drop in temperature, but the year without the summer is 1816. Yes, 1816. Right.
So Tambora apparently was a 7 on the volcano explosivity index.
Yeah, and Krakatoa was 6, I think. 6.
Krakatoa was a 6, yes. Mount St. Helens is a 5.
Yeah, this could be a 5 or perhaps a 4.
Yeah, it's either high 4 or low 5. I tend to agree. For comparison, for the European people who don't get to see many volcanoes, in 2010 when that volcano in Iceland called Eyjafjallajökull broke out, you know, the one that fucked up the air travel. That was a 4. And I remember again that this scale is logarithmic, so a 5 is 10 times stronger than the 4, and the 6 is 10 times stronger than the 5.
That Tambora one, then, presumably that made a louder. Was it a bang that Tambora made? That'd be louder than Krakatoa.
I'm not sure. Probably, maybe. Eruption. So let's see. It doesn't look like it. No, it didn't. It looks like it didn't blow up. It was more like just a lot of outflow, basically, for a longer time.
Right.
Mm-hmm.
So, oh god. According to Wiki, the amount of ejecta was 160 cubic kilometers.
That's quite a lot, isn't it, really?
Yeah, with a total mass of 140 billion tons. Yeah.
Yeah, I mean, it makes atomic bombs look very pathetic. These
yes, it does. It really does. I mean, I wouldn't be surprised if the one we saw yesterday was more than the biggest nuclear bomb that we had.
Absolutely, much bigger than it. Probably almost equivalent to an arsenal.
Yeah. So the Tambora, according to this article, was estimated at 30,000 megatons.
Right.
For comparison, the biggest nuke that humanity has had 50 megatons.
Exactly, it's a huge, several orders of magnitude difference.
Given that I don't think that there is a nuclear bomb that has caused a shockwave that has been felt all over the Earth.
Well, I think the Tsar Bomber one was actually measured at least once when traveling around the planet.
Okay.
Give me a second.
Or at least measured, because I wouldn't think people on the other side of the world would have heard.
No. But they would feel it, not feel it, but measure it definitely with instruments.
Yeah.
So let's see.
It would be really suck for the fish in a vicinity. Like, oh, why can't I breathe now?
Consequences, test results. Atmospheric pressure wave resulting from the explosion was recorded 3 times in New Zealand. Station in Wellington recorded an increase on October 30th. Northwest and southeast. So this one also traveled around the planet 3 times.
Wow.
Okay.
Yeah. So that's why I'm saying that's one of the reasons why I'm saying we're gonna see more from the volcano in Tonga. We just hasn't been enough time for it to travel around the planet twice.
Yeah. It was definitely amazing. like horrifyingly amazing, but still amazing nonetheless.
Yeah. Yes, it's one of the things I don't want to be close to.
Yeah, I've seen this was like a once in a 1,000-year event. Also, like
this one, no. This happens. Volcanic explosivity index 4 event happens every few years.
I mean this specific volcano on average every 1,000 years. Yeah. So of course worldwide you have like of course other volcanoes, but I meant this volcano specifically. Yeah.
It's also sweet that we were able to film this. I mean, just imagine 50 years ago, right, when global surveillance satellites weren't really a thing yet. I mean, they existed, but would somebody use them to, check out Tonga while there's Soviet stuff to spy on?
Yeah. Also, I was wondering, did we knew about this volcanic eruption from the space satellites at first, or?
No. So this was not the first eruption that this volcano had produced in the last few days. There was an earlier one about 3 or 4 days ago. So it was clear that the thing was active. They had people in boats around it to monitor it. So let's hope those people got out. But they didn't have any special satellites, looking at it on purpose, as far as I'm aware. The one where you always see these nice pictures of it. One of them is just that's a Japanese weather satellite, which is supposed to track storms, and the other one is an American one. Yeah, that's a Himawari 8. Yes, correct. And the other one is an American one, whose name I forgot. Just give me a second. I think it's Geos West or Goes West. Goes West, that one. But the main one is Himawari.
I will.
By the way, there's going to be sunrise in Tonga in about 1 hour or 2. Hello?
Like I was wondering, what is the time window for the CGI guys to render this image for the flat earthers?
Yeah, I'm really curious to see
how long
how they are gonna explain this. I mean, it's obvious that there's no flat Earth map that can explain this. It's so super clear that this absolutely shows without a shadow of a doubt the Earth's sphere.
Well, they ignore all the other compelling evidence. I mean, for Christ's sake, look at these pictures you're looking at now.
Yeah, that's true, but you don't need the pictures. You just need those stupid 2 data points.
Yeah, but that's maths, Gio. You know what they're like with maths.
Oh yeah, I forgot. There's only 3 things you need to know. When did the eruption happen? That's number 1. And when did you measure those 2 points? Those 2 pressure waves. That's all you need to know. You don't need to know the speed of sound. You don't need to know where on the planet you are. Right? As long as you have at least 2 observers.
There was a debate last night with Fight the Flat Earth and some guy, some flatty, and Fight the Flat Earth was offering information, engineering drawings and things, and this guy's response always, well, they're just lying. They're just making it up. So that's with every piece of evidence he provided, he was just saying they're lying. So that's unfortunately, I mean, that's obviously one contingent of facts. Some of them are a bit more susceptible to recognizing and people's qualifications. Surveyors, well, they're just pretending, or they're just a story. So every piece of evidence that's presented, he was a particularly annoying flatty. And obviously some of them are just going to say that all the evidence you're presenting is made up or a story. Obviously you can't argue with people like that, because obviously the only tools we've got are evidence and logic and reason and science. And if you're going to deny all of those, then you can't get very far. But yes, those who are prepared to accept that the media is telling the truth and that these people who are qualified to be surveyors and people who design things and data we do get in from scientific instruments are true, yes, they're going to have a big problem.
Yep, even that, I don't think I used any data that didn't come from, amateurs, apart from the satellite imagery to find out when exactly the explosion happened. But again, that can be tracked just by eyewitnesses.
Yes, I was a bit surprised that. I mean, there's the pressure data I think you can get from meteorological stations in this country. I mean, things like airports.
Yeah, but this wasn't even official data. This was just people on Twitter looking at the barometers.
Yeah, that's what I was wondering. Why didn't you use some of the official data, or do you deliberately not do that?
I mean, I could, but then again, I just took the first data I found because that is already enough.
Right. Okay.
But official data is fake, obviously.
Oh, that's what I'm saying. Yes, I was just wondering if that's why Geo done it that way.
Yeah. So again, just look at this. Isn't it beautiful?
it tells a story, doesn't it?
Yeah. I mean, I could now sort them by distance from the volcano, because then you obviously get a nicer graph.
Yes.
Yeah, because there would kind of be a linear correlation between the first data point in the distance and a negative slope on the second one.
You need one graph showing the distance according to the round Earth model, and another one showing the distance according to the flat Earth model, and see how which one matches.
That's why I wanted Sly in this hangout, because he would be able to draw this or show this much more nicely in one of his models than I can. Right?
Yeah, I should be Maya competent. I should really be able to do that, but okay.
Yeah. But it's already super clear.
Yeah. Well, of course, Google Earth allows you can plot these spots, can't you? Yes, I mean,
Yeah, the only thing that if Google Earth allowed me to basically pop in the positions at a certain time, I could just turn it into a movie, right? And then say, okay, at that certain time, it was measured here and there and there. And then the same for the second data point. It should be super nice to see it. But I don't think Google Earth allows me to do that. If it does, I would instantly do it.
Yes, I'm not quite sure what scripting controls you've got.
I have no idea.
Yeah.
But yes, we need that. That's one of the reasons why I would like to have Sly in this project, right? Because he can model this much more nicely than I can.
I mean, this program is amazing. When I first became aware of it, whatever it was, 10 years ago or something.
Which one?
Just thought.
You mean Google Earth?
This one, Google Earth. I mean, just amazed to think we can discuss a location, and then we can just zoom into it, go to that thing, and you're doing there with Tonga, just go straight in there, and then see pictures of the historical things. And this is. When I first found this, I thought this was absolutely unbelievably unbelievable. The fact that we suddenly got this power to go anywhere in the world, see what's there, and show distances between them, and plot things out. And I mean, it's just amazing, this program.
It's the entire internet, the amount of information we now have, or information that we have on our fingertips. Right.
Yeah, I mean, today, for instance, I was trying to mess around with planar equations, and I was just thinking I'd known about it from my university days, and I was just thinking what I'd have to go and do, what I had to remember about it then, and what books I'd have to reference, and then I could just bloody Google it, and within about 2 minutes, I could suddenly have all the better information in many ways than I had, in my bloody maths books. Just incredible.
All this information for free. Unfortunately, it also allows a lot of bullshit to go through.
Yeah, that's true, but that's what we are for. Even though there's this thing called the bullshit asymmetry principle, which means that it takes an order of magnitude or two more of time to debunk bullshit than to produce it.
Yes,
right.
True. Yeah.
But this was just so easy to do today. Right.
But fortunately, it's quite easy for people who've got a brain. It's actually quite easy to differentiate the good information from the crap information, just the way that people put things together. It's quite easy, reasonably easy to discern the difference between them. But it's obviously rather stupid people can't tell the difference, and they're the ones with the problem, as usual.
So here's a question I have to you. Do you think flat earthers are going to talk about this volcano eruption?
If we're rude to them, make a big fuss about it, possibly, but they'll try and ignore it. I mean, obviously, what they'll do, because they like sticking their fingers in their ears, if they can avoid talking about it, they will.
Let me just
unless they get some angle.
I will guess that they will just say like, oh, a volcanic eruption is just irrelevant to the shape of the Earth. So there you go.
I mean, what this entire setup is basically just a giant pinging, right? You're pinging this volcano like you're pinging a server.
Well,
that's rather they travel. It's very important, this direction business, the way the wave propagates. I think that it can only come from behind you. If it's going out in one direction, it can only come back along that great circle route, which I don't think is quite true of internet pinging.
Well, I know that the analogy is not perfect.
Also, didn't the flat Earth movement lose some steam in the last years?
Thankfully, it did, yes. But they actually moved on to something more dangerous.
Oh, right.
Which is obviously anti-vaxxers.
Yeah. It looks like Mitchell from Australia talked about it a little. He's made a video about it.
Who?
But that's just about apparently he's managed to debunk the satellite pictures from space.
Oh, yeah,
Mitchell from Australia. This is Joe. He's a guy who turned up in the last few months who's a real flatty. Thinks sextants cannot work on on the globe Earth, and he doesn't understand how they work. But he's prepared to go on and on about how they work, even though it gets it wrong all the time.
Anyway, you can get all the data. Yeah, I can just send you all the links where I got that from. You can have that, and you can just go to Twitter and look for people uploading the screenshots of their barometers. And you can plug it into the equation and see if it also works for you. So just for information, so it looks like the round trip time once around the entire planet is about 36.5 to 37 hours, right? Which means that the halfway around time from the volcano to the antipodal point is something like 17 thereabouts.
18.
Yeah, 18. Yeah, sorry. Oops. 18 and a half, something like that.
Yeah.
And I would be really surprised if there was a data point, a legit one that's actually off of this. Because I don't see how it could be.
It's also something about the shape of the wave. Like at first you have like a high pressure, then a low pressure, right?
Yes, we were wondering what causes that, and I'm still not sure about it.
Maybe it first like pushes air out and then it collapses inward, and that's causing a low pressure. Maybe
that's what I thought as well, but I really don't know. I really don't know.
Yeah, I don't think that's going to work, because if you just imagine getting the second one is just simply coming from a different direction, but the pressure wave is not behaving in any different way. It's just taking longer to get to you. It's not a different sort of pressure wave. It's just simply coming from somewhere different.
Yeah, unless there's some really weird interference going on in the antipodal point. Yeah. Again, I really don't know why the second pressure wave in many cases shows up to be, the opposite. Why it's under pressure going first and then the overpressure, not the other way around. I really don't know.
It's weird. I can't think this. I don't understand that.
Well, I think I'm gonna call it a day.
Yep.
That's
all right.
So
sure.
I'm going to upload all the sources for these data points into the description of this Hangout, so that everybody who wants it can have a look and recreate it and maybe add additional data points. But these 8 already for me are pretty clear. And the challenge goes out again to Flat Earthers to explain what the fuck is going on. Because I don't think they can. So thank you very much for watching. And have a nice day.